Hi everyone, this is Sharan here. Welcome to my channel. Today is the second day of exploratory data analysis using the Titanic Dataset, and what we are going to cover today is about data transformations. So today we are going to see in detail about transforming categorical data which is in string data type. For example, if we take gender as an example, so the data could have a string as male and female, or it could have simply M and F. So we are going to see about transforming this into an integer like 1 and 2 for male as well as female. The reason why we are doing this is, so not only for a gender, for any other similar categorical data. For example, if we take the Titanic dataset, which we have seen in the previous session, we have various categorical data such as the embarked, like from which port the passengers have boarded the ship. So there are three possible options. So we have alphabets such as C, S, and so on for the details about like which port they have boarded. So we need to transform this into an integer category. Like for example, like if people have boarded the ship from Southampton, maybe let's say 1 for it. So transforming these string or character data type into an integer categories. The reason why we are doing this is there are two reasons. So one is when we instead of using a string, let's say we are using an integer to represent all those categories, the benefit is it will utilize much less memory space. And the other reason is, for example, the algorithms such as SVM and regression algorithms, they are algebraic algorithms, which means that the input that we are going to pass should be numeric. So if we are going to pass on an feature or a column which has various categories and of data type string, so it can't be utilized in case of these algorithms. In some algorithms, what happens is all these categorical variables or features which has a string, it will be transformed into an equivalent numerical format, and they will be still utilized. They will be still utilized in the model. But in these cases, in many algorithms, we need to convert these string categories or the string data into an equivalent numeric data, so that we can use all these values in our model. So that's the main reason for doing the data transformation. So today in this session, what we are going to do is we are going to pick up the same example, the Titanic dataset example, and we are going to see about the different ways of doing the data transformation, like the different techniques and how it needs to be done. Let's go into the tutorial and then see how it has been done. Continuing from where we left in the previous session, so we have done the data analysis so far. So now moving on to the data transformation. As you see on my screen, what we are going to do is we are going to transform this column. So instead of male, we are going to replace it with the value 0 and female with the value 1. So as you see on my screen, what we are doing is we are doing the replacement or data transformation for both the test as well as the trained data set. So in this case, like the title dataset that we are working on, it has both the training dataset and the test dataset. So whatever changes that we do to the training dataset, the exact same changes should be done to the test dataset as well. So that what happens is whatever the model that we are trying to build on the training dataset can be used on the test dataset in order to make the prediction and make the submission as well. So what you will be seeing is you will be seeing that in whatever changes that we are going to do, we will create an array and then pass on the data frames train as well as test to it, and we will use the for loop to make changes to both the train and the test data set. So whatever changes that we will do will be exactly same across both of them. So here in this case, what we are doing is we are creating a kind of a set where we say for male the value should be 0 and then for female the value should be 1, and what we are doing is we are passing on the train and test data set into an array called data, and we use the for loop and then say for this particular column sets, we use the mapping, whatever input that we have given here, where whenever the value male comes up, it will be replaced with the value 0 and female will be replaced with the value 1. So in order to show that, so let me execute this one. So as you see now, the column sets has male as well as female, as you see on the screen here. So now I'm going to execute this particular command here, and then let me re-execute this now. So now if you can see, so the male and then female values are now replaced with 0 and 1. So now what happens is, previously, like if we are going to use any regression algorithm or like SVM algorithm, when these values are represented as a string, it is not possible for us to use these columns directly into the model. So now by replacing them into an integer equivalent, what happens is now we can use all these attributes in our model while making the prediction. So we haven't gone yet to the prediction, but what we are doing is when we are doing the analysis, the objective in our mind should be about what we are going to do. So if it is analysis, it's all fine, like we need not worry about the data transformation, at least these kinds of transformation. But if the objective is to build a predictive model, so then of course we need to ensure that the data transformation is done in order to ensure that it is being usable by whatever model that we are choosing. And then similarly, the second one is embarked. So embarked had value S, C and Q. So this is also a string data type, so it will be represented as an object. So now we are going to transform this into an integer, categories of data type integer. So when I execute this, and then if I can show you the unit values now present in the column embarked, so what happens is the values are now 0, 1 and 2. So I can show you what happens to test as well. So it will be exactly same. So whatever transformation that we are doing to the training data set, the exact same transformation should be done to the test data set as well. Like the train and test should be exactly same. All the transformation that is being used should be same, because whatever model that has been trained on the training data set, if we want to use it on the test data set to make the actual prediction, so both of them should be aligned to each other. And that's about the change. And moving on to the next one coming to the fare. So we noticed that the fare, like there was one record which was null in case of test data set. So what we are doing is if any null is being found, we are going to replace it with a 0. So in this case it made sense, because like most of the values are anyway skewed towards 0. And then there were very few outliers, but majority of them are skewed towards 0. So we can replace it with 0, or maybe you can choose to replace it with mean value. Or if you want to make an most accurate replacement, what you can do is you can see the average fare depending upon the class as well as the age, and you can use the mean for that particular category and then replace it in here, instead of replacing it with 0. So maybe that would be more accurate. But here in this case, there is only one record that is missing, so it's not going to be a big impact on the model. So I'm going to just replace it with 0. And then what I'm doing is, so this fare column is an float. So age and fare were float data type, if you remember from the previous session. So here what I'm going to do is I'm going to convert this into an integer. So anything after the decimal point, I'm not going to be worried about it anyway, because the range is already too high. So let me execute this here, and so now what would happen is the fare column in both training as well as test data set would have been transformed into an integer data type, and anything after the decimal point would have been dropped. In case of test, like the one record which was missing the fare details, so what would have happened is the value would have been replaced with 0, because we are using fill NA with 0. So that's about what we are doing here. So next one, moving on to the age column. So what I'm going to do is I'm going to first check the number of records that has null value for age. So as you see here, so we can see there is a number of records, like a huge number of records has null value, not a number, for age attribute. So we are going to see how to handle this. So while handling these missing values for age, what needs to be done is, there are many missing values in both training as well as test data set. So if we are going to replace all the null values in the training data set, and if the test data set are left untreated, so what would happen is, while building the model, the accuracy might not be really good, because the test data set suddenly has a huge number of null values, and maybe the model might not know how to handle it because it wasn't be trained for those scenarios in the training data set. So what we are going to do is, we are going to use the same logic that we are going to apply for the training dataset on the test dataset as well. How we are going to achieve this? First, what we are going to do is we are going to combine the test and train dataset. So as you see here, I'm going to use concat functionality to combine the test as well as training. While doing the concatenation, what I'm doing is I'm adding a column called indidata, where I'm saying that all the training dataset should be called as should have the value called train, and the test dataset should have the value test. And I'm going to ignore the index. Ignore index is set as true to ensure that we are not reusing any index from the original data frame train as well as test. So now what we'll do is this script here, this line here, would ensure that the train and test dataset are combined together. Okay, so after combining them together, now what we are going to do is we are going to first identify the index position which add the null value for age. So whenever the age column is null, what I'm doing is I'm getting the index position and passing this value to age, not a number, position. So wherever the attribute age is missing, those index values will be captured here. So now I'm going to go through these index position from I is equal to 1, like first position to the end. And what I'm going to do is I'm going to take the average. So whenever like the age is missing for a particular record, what I'm going to do is I'm going to pick up the title of those particular record. So here so far, like in this particular data set, we haven't really used a title. So title is an attribute that has been newly created. We will see how this attribute title is being generated in the next session. But for now, what I will do is I will just execute the script here to create the new feature called title. So title is nothing but like Mr., Miss, Master, or Mrs. depending upon the age and whatever has been captured in the name of those passengers. So if you see here, we can see the title are being present in the name. So what we are doing is we are just extracting these titles, and depending upon the title, whenever the values for age is missing, depending upon the title, the mean values are identified and it will be replaced accordingly. So for the missing value, we get to know what is the title, and we see for that particular title on the whole data set what is the average value, and replace the missing value with that average value. If you want to make it more sophisticated, maybe you can combine the title information along with maybe class or any other fare or any other details, and accordingly you can replace it. So whatever you feel is the most accurate replacement. So now what I'm going to do is I'm going to replace all these missing values depending upon, based on the title, the average values will be replaced. Okay, so now still the title is not available, so I'm going to rerun the concatenation, because like after creating the new feature title, we haven't concatenated this. So I'm going to re-execute this, and now when I execute this, so now it is fine. So it is just executed with some warnings. So let's ignore the warning. And moving on to the next one, what we are going to do is we are going to again split the test as well as the training data set based on the indicator that we have created. So now I'm going to, after combining, we have done the replacement, and then now we are going to split them again. The reason why we are doing the concatenation and then doing the replacement is, if we replace the train as well as test data separately based on the averages within the train and within the test data set, it might not be really accurate because the training data set is slightly bigger. So for that reason, for the uniformity, what we are doing is we are combining both of them together. We are getting the average and then replacing them, so that the logic or the conditions that is used for replacement in training as well as test would be exactly same. So now I'm going to test if there are still any more null values in the training data set. So we can see that there is no more null values for age, everything has been replaced. So now the age values are replaced. So but still what we have noticed is the age ranges from maybe like approximately from less than 10 to almost 80. So it's a huge range. So what we are going to do is we are going to convert the age column from a numeric column, from a continuous integer column into a categorical column. So here what we are doing is we are giving the value So if it is less than 15, we are setting the value as 0, 15 to 30, so then the value 1, and so on. So now let me execute this, and again it is executing based on with some warnings. So we can, for now we can ignore the warning, and so let me see the unit values for age. So now we can see that age values are ranging from 0 to 4, depending upon the category in which the passengers are falling into. So now we have replaced an column with a continuous number into an categorical data type, and that's about the various transformation that are usually done on on a data type that is very similar to a Titanic Dataset. So the next one is, after doing all these changes, we can just drop off all those columns which is no longer being used. So in this case, ticket doesn't show any, so ticket values looks like a completely random numbers. So it doesn't seem like it will be used. It will be useful for the model or the data analysis. So we are dropping off the ticket column. Similarly, cabin, about 2/3 of the data is missing for cabin. So we are dropping it off, and the indicator, which was created in order to concatenate the train and test data set, and no longer being used. So we are going to drop off all these 3 different columns, and finally, so now all the data type I tested is converted into numeric type, so at least numeric category. So let me show you the top 5 rows for. So as you see here, now all the columns are of data type numeric. So now we are ready to maybe utilize the data as such in our SVM model or any other iteration model. So before going into the next session, so we are not going to see about building the model as of now. So we are still doing the exploratory data analysis and feature engineering. So when we come to the model, if we are good enough to build a particular model, what I am trying to say is the dataset that we have right now is good enough to be used in the model. So next one is doing the correlation for all these columns. So now, since everything is in numeric format, we can do the correlation for all the attributes that are available, and we can see how 2 different attributes are related to each other. So when we see a positive value, so a positive value of perfect 1 means when the attribute here increases by 1 unit, the attribute here as well increases by 1 unit. So the diagonal is perfectly 1 because it is self correlation, the same attribute. And whenever the value is in negative, it means that when one value increases, for example, fare and P class, passenger class, or negatively correlated, which means that as the passenger class increases, which means that from 1, this is a categorical value from 1 to 3. 1 is first class and 3 is third class. So the third class, the fare would be very less, whereas for first class, the fare would be very high. So one attribute increases, the other attribute goes down. In case of positive correlation, so we can see gender and survived is positive correlation. So both of them are categorical values, and coincidentally what happens is the value 1 means that survived in case of survival flat, and 1 in case of gender, 1 means female. So female had a higher probability of survival, and hence we can see there is a positive correlation here. So maybe if we had given the value, if we had swapped the value for gender, it would have been a negative correlation, but it doesn't matter, right? We are able to see how the patterns are. So correlation is very good to see the patterns. In some cases, for example, embarked. So here the values that we have given, 1, 2, and 3, representing the port in which the passengers have boarded, doesn't exactly mean anything. So it's just a numeric value that is being given to each of those categories. So 1 doesn't mean or 3 doesn't mean that it's higher. So it's just 3 random values. So in these cases, for these columns, maybe it's not useful to see how the correlation is performing, because all these 3 values are completely a random value. But it is not the case with the passenger class, because passenger class 1 means that class 1, and then 3 means class 3. So there is some kind of like, we can still use it for correlation, but embarked is something that we shouldn't be using for correlation, or at least we shouldn't consider the output that we did here for this particular column. So that's about the data transformations. So if you have learned something new, please give a thumbs up and subscribe to my channel. And tomorrow or in the next session, we will be going through the various techniques that can be used for creation of new feature, right? How to use the existing attributes and really come up with a new feature, maybe which can help the model in improving the accuracy. Yeah, that's it for now. See you in the next session. See ya. Bye.